I just want to touch on today a couple reviews for fractions because it's so important to get the concepts of fractions down before we move on and start applying them in different concepts. So again, we know a fraction is an equal part of a whole or a group, and today we're just going to be talking about an equal part of a whole. Fractions consist of two parts: the numerator, the number on top, and the denominator, the number on the bottom. The bottom number is called the denominator. That tells me how many equal pieces in the whole. So if my whole, and I'm just going to use a fraction bar because it's easy to split up, 3 tells me there's 3 equal pieces in that whole. My top numerator tells me I'm referencing or I'm talking about 2 of those. So this fraction bar, which is one whole bar, is broken into 3 equal pieces, and I'm talking about 2 of those. So this is 2/3 of the whole. Again, my fractions have a denominator on the bottom, a numerator on the top. Now my denominator tells me 4 equal pieces in a whole. Again, I'm going to do a fraction bar, and I'm going to split it into 4 pieces. If I want the whole fraction bar, which is a whole number, 1, 2, 3, 4, that's 4 pieces in the whole. So my bar is split into 4 pieces, and I'm talking about 4 of those. So 4 out of a 4. 4 pieces out of 4 pieces means the whole thing. So 1 equals 4/4. It means I have all the pieces. Going back to that fraction bar that was in 3 pieces, 1 equals, if it had 3 pieces in the whole fraction bar, or the whole, would be 3/3. So 1 whole equals my numerator and my denominator being the same. It could be something random like 127 127ths. That still equals 1. Whenever my bottom denominator that tells me how many pieces make up the whole is the same as my top numerator, it means I have the whole thing there. I have 1 whole. Whole number, fractions. Fractions are equal pieces in the whole. So if I'm going to equal 1, I'm going to do 1/4 plus what equals 1 whole. So I'm going to solve, I'm going to make that n, little algebra in there, the unknown. So this tells me I have 4 pieces to make a whole, and I've got 1 of them. 1/4 plus how many more equals 1 whole. How many pieces do I need? 1, 2, 3. I need 3 pieces, and what size are they? 4ths. So n equals 3/4, or 1/4 plus, now I know what n is, 3/4 equals 1 whole. Notice my bottom denominator stays the same. When I'm adding, I don't add my denominators together because those are the size pieces. Here's 1/4, then I'm going to add 3/4 more. 1, 2, 3. So 1/4 plus the 3/4 equals 1. It equals 1 whole. I have 4 of the 4 pieces. I have the whole thing. What about if I have 2/5 plus 1/5 plus, I'm not sure what, equals 1. Remember, I want 1 means the whole thing. My size pieces are 5ths, so that means that whole is cut into 5 equal pieces, or divided into 5 pieces. Here I have 2 of the 5 and 1 of the 5. That's like adding 2 plus 1 are 3. So I have 3 of the 5 pieces, but I need 5 whole pieces. So 2/5 plus 1/5 so far is 3/5. So I have 3/5 plus how many more fifths equal 1? And we know 1 equals, if my bottom denominator is 5, my numerator has to be 5. So if 1 equals 5/5 and I have 3/5, how many more of those pieces do I need? 2. You're right. N equals 2/5. I'm going to put that in there. 2/5. So now my bottom denominator stays the same. Those are all the same size pieces. I have 2 of them. 3, 4, 5. 5/5. 1 equals 5/5. It's pretty cool how that works. Then what happens when I want to add 3/5 plus another 3/5? Remember, my pieces are fifths, so that stays the same. Now I'm just going to add my top numerators. 3 plus 3 are 6. 6/5. 6/5. Whenever my top numerator is larger than my bottom denominator, that tells me I have more pieces than I need to make a whole. That's called a fraction greater than a whole. So now I take that and I simplify it, or I put it into a mixed number. A mixed number means it's a whole number, so I can make some wholes out of this and have fractional pieces. So I can do that as a picture first. So remember my fraction bar, since it's 5, I need 5 pieces. And I have 6 of them. 1, 2, 3, 4, 5. Oops, gotta make another one. 6. There's my 6/5. 1, 2, 3, 4, 5, 6. So what does that show me? I have one whole, because I filled up the whole thing, 5 out of 5 pieces, and I have one piece left, and they're fifths. So 6/5 equals 1 whole and 1/5. Let's look at it this way. 6/5 equals 1 and 1/5. I can draw a picture to solve that, or I can also do it by division. I can divide, since I only need 5 pieces to make a whole and I have 6, I can do 6 divided by 5. How many 5s are in 6? 1. 1 times 5 are 5. Subtract remainder 1. I have one whole. There's my one whole. And I have one piece left. There's my one piece. And what size are they? Fifths. 1 and 1/5. 1, remainder 1. Math is patterns. Let's try 14/3. 14/3 is a fraction greater than a whole. It means I only need 3 pieces to make a whole, but I have 14. I'm going to take 14. I'm going to divide by 3. How many 3s are in 14? I know my multiples, so I can go 3, 6, 9, 12. So that's 4. 4 times 3 are 12. Subtract 2. 4, remainder 2. So 3 goes into 14 4 times, and my remainder is 2. I have 2 pieces left. Those pieces are thirds. 14/3 is equivalent or equal to 4 and 2/3. The more you do this, the easier it gets. You find the relationship between numbers, between operations. We'll go with 16/5, fraction greater than a whole. 5 pieces to make a whole. I have 16. So how many wholes can I make out of that? 16 divided by 5 equals 3, remainder 1. That's 3 wholes, 1 remains, and it's a fifth. 3 and 1/5. So going from a fraction greater than a whole to a mixed number. And we can do that backwards. If we need to switch to 2 3/4, which is a mixed number because I have some wholes and I have some fractional pieces. I'm going to make this a fraction greater than a whole. My size pieces are fourths. That means I have 2 wholes. We can do this 2 different ways. 2 wholes means that would be how many fourths to make a whole? Remember, my numerator and denominator are the same. So 4/4 is 1 whole. So it would be 4/4, which is 1, plus another 4/4. So that's 2. There's my 2, plus my 3/4 equals, my bottom denominator stays the same. I have 4, 8, 11/4 equals 11/4. But what did I do right here? This looks like 4 times 2. Doesn't it look like 4 times 2 because 4 pieces make a whole and I have 2 wholes? Then I added my 3/4. That looks like 4 times 2, 4 times 2 plus my 3 equals 11. 4 times 2 plus 3 equals 11. Seven 4/9. That's a mixed number. We're going to make it a fraction greater than a whole. I have 7 wholes, and I'm dealing with ninths. Ninths is my denominator, so it takes 9 pieces to make a whole. So that's like 7 groups of 9. 7 groups of 9. Groups of means we're dividing. So it means 7 times 9, because that would be 7 wholes, and there are 9 pieces to make a whole. So 7 times 9 plus my 4 I have there. 7 times 9 are 63, plus 4 are 67 ninths. So 7 4/9 are equivalent or the same as 67 ninths. It's going from a mixed number to a fraction greater than a whole. A fraction greater than a whole to a mixed number. It's the same thing as multiplication and division. Remember the inverse. It's a way to check, to switch back and forth. Two and 3/4 plus 3 3/4. Now we're adding mixed numbers. When you add mixed numbers, you start with the fraction pieces first. My denominator is 4, so it tells me 4 pieces to make a whole. I have 3 plus 3 is 6. I have 6/4. What do I know about 6/4? That's more than a whole. I only need 4 pieces to make a whole. I have 6. So I could do 6 divided by 4. That's 1. Remainder 2. That means 6/4 equals 1 2/4. So I could add my 2 and my 3 and make it 5 plus 1 2/4, and then it would be 6 2/4. Or I could change my 6/4 right here and do my 2/4 here and put my 1 up here. 1 and 2 is 3 and 3 is 6. 6 2/4. So I can either make it a mixed number right here and make it 2/4 and the 1 here, or I could put it down here 1 2/4 and add it to my whole number. The more fractions you do, the different ways you'll find to do them that are easier for you, the fewer steps you'll need to take. Now we're going to subtract mixed numbers. Same thing, you always start with the fractional pieces first. Here I have 1/5 minus 3/5. Same thing as if I were doing whole numbers. I can't take 3 away from 1. So what do I need to do? I need to regroup. I go over to the wholes. I have 7. 1 less than 7 is 6. So I'm going to add 1 to this number. 1/5 plus 1 whole. And what do I know? If my bottom denominator is 5, my top numerator has to be 5. 5/5 is the same thing as 1 whole. So I'm taking that 1 whole from over here and I'm turning it into a fractional whole. So I can get some more pieces in my numerator. So 1/5 plus 5/5 equals 6/5. 6/5 minus 3/5 are 3/5. 6 minus 3 are 3. I could do it this way, or once you get to doing it more often, you'll find that I can go, oh, 5 pieces in a whole. I'm going to add those 5 pieces to the one on the top and just make it a 6. So there's different ways you can do it, that you can skip steps once you've done it more often. But I want you to know how we get that way, where that 1 whole comes over here to 5/5. We'll try one more subtraction. 8 1/3 minus 2 2/3. Again, I have 1/3 and I can't take 2 away from 1. So I'm going to go over to my whole numbers. 1 less than 8 is 7. And I'm going to add 1 onto here because this is 1 whole, so I'm adding 1 whole over here. 1 whole, if my denominator is 3, means my numerator has to be 3. 3/3 is the same thing as 1. That's the one I took from here. So 1/3 plus 3/3 are 4/3. So I now have 4/3 over here, and I'm going to subtract 2/3. 4/3 minus 2/3 are 2/3. 7 minus 2 are 5. My answer is 5 2/3. If you have questions, please let me know. Go back and stop and watch it again and try it yourself. The more you do something, the easier it gets.